Hello and welcome back, guys. So in this particular session, what we'll be doing is we'll be solving this particular problem where we need to check if a number is colossally uh, abundant or not. Okay. So basically, what that basically means is that the divisor is greater than the number itself, the sum of its proper divisor. Okay. So basically, let's say we have a number 12, right? So it's divided. It could be divided by what? 1 2 3 4 5 and 4 and 6, right? So what is the sum of all this thing? So sum will be 6 4 10, 3 plus 2 15 and 16, right? So that's greater than divisor, right? So how do we compute that? Right, so basically we can have divisors, let's say, right? So divisors list kind of thing, right? So we just add it. So for I in a range from 1, of course 1 it can be there, and then n, right? So then what we can do is we simply add the divisors, okay? Or we don't even need to add the divisors. Basically we simply need the sum equals to 0, and then if uh, n divide by I equals right, I mean it should be modulo, right? And equals 0, that means we can simply do sum plus equals to, okay, plus equals to what? I, right? So we simply add the number, okay? So if there is 12, right? So if there is 12, so what we can do is we can simply use 1, and then 1 comes over here. 1 divide n divided by 1 will be, of course it will be 0, right? There will be no remainder. 2 will be same thing, 3 will be same thing, 4 will be same thing, 5 it will be, there will be a thing, right? So there will be a divisor value. We could maybe do it like this as well, where we can simply do divide by 2, right? Just under rooting it. Or we could simply do into 0.5 as well, okay? So mostly half should do the job, okay? Half should do the job basically. So we don't need to loop over everything now. We don't need to check if 11 and all as well, right? So we can simply look up only until thing. I think sum is not a proper word, right? So uh, 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 would be better. It's a keyword, right? So let's run the code. Should be all right in my opinion. What is it? Float cannot be interpreted. Okay. Was there any float? Okay, so let's just do 1 at the moment. Right, let's see. Okay, number was 6, and then it should have been true. Oh, okay, we don't just need that. We need sum is greater than n. Right, that's what we need to check for. Let's see, 6. Right, why did it? So 6 can be divided by 1 2 3. Right, 3 plus 5 plus 6. So it should be equals to as well. Okay, we need to add that condition as well, greater than or equals to, right? So now it should be fine. I just want to check, is there any float number that comes up though? Right, maybe what we can do is into 0.5. Right, in that situation it might say float blah blah blah, all this kind of thing, right? Object can be interpreted as an integer. Okay, great. We can simply do int, convert it, right? In that situation what happens? So what happens? 6 half is 3, right? So half is 3. Okay, we will need to do plus 1 over there, I guess, right? So this will be 10, and then there should be 10 as well, so that's why it's complaining. Okay, So we can do +1 because 10 is not being included, na? Because range, this is not inclusive when it's going over the loop. Right. So when we do this, it should work just fine. Okay. So let's submit the code. Right. Okay. Let's see the solutions that other people have proposed. Okay. This it's doing something similar and then just using thing. Okay. It's just getting the I and then if it is thing and then it's making a list. Basically what I was about to do, but same thing. Okay. What about this guy? This guy is doing half and then +1. Okay. Great. Proper divisors. Okay. Something similar, I guess. Yeah, doing a list. Maybe list comprehension could be better over there. List comprehension. Right. Okay. So basically, the solution to this is basically just doing half and then doing +1. Okay. Basically, of course, there will be 2 or 3 that will come up, and then when you multiply by that, you won't be exceeding by that value, right? So that's how we can solve this problem. Okay, so see you in the next video. Take care. Thank you.